Good morning, everyone. It's morning in Calgary, late morning, beautiful day. It's lunchtime in Prince Edward Island. I saw Kevin's dog walk over, probably not interested in methane, but mostly because of the smell of the food. My name is Marc Godin. I'm with PTAC, the Petroleum Technology Alliance Canada. I'm also the co-lead for the CRIN methane theme, and it's my pleasure today to host a session. I'll start with the land acknowledgement and some logistics comments, and then an overview of the agenda. Acknowledgement of the land is an important step toward reconciliation. In the spirit of reconciliation, we acknowledge that we live, work, and play on the traditional territories of the Blackfoot Confederacy, including the Siksika, the Kainai, the Piikani, and the Treaty 7 tribes comprised of the Tsuut'ina and the Stoney Nakoda nations, and the Métis nations, Métis Region 3, and all the people who make their homes in southern Alberta. The session will have the following speakers. Each one will have 5 minutes to provide an overview of their technology and project that is funded by CRIN. So in order, we will the speakers will be AIRMarket, Arolytics, Calscan, Ionada, and closing it out, Kinetics Automation. After their brief remarks, we will have the Q&A, the question and answer period, where we invite you the people here in the audience to raise your hand, and we'll bring a microphone to you so that your questions can be heard online. And for those online, please put your questions in the question and answer feature at the bottom of your screen. A few words on the methane theme. So methane emissions reduction is a critical element of any greenhouse gas reduction program. So Canada has signed on in international obligations to reduce its emissions of methane from oil and gas, agriculture, and municipal and other sectors. And it is critical that we have the technologies to accomplish that goal. But also notably, methane is a large component of greenhouse gas emission, and without action on methane, it's going to be nearly impossible to meet commitments on the broader greenhouse gas subject and address the problem of climate change. So it's in this context that we provide this information and these technologies. So it's my pleasure to invite our first speaker, Lindsay Mohr of AIRMarket. Lindsay is joining us online from his location in Edmonton, and I've worked with Lindsay for many years, and he has an exciting project that he has been developing for several years, and I'll let him introduce it to you. Over to you, Lindsay.
Excellent. You can hear me, everyone? Am I coming through? Excellent. Yeah, you might consider myself and Marc an old married couple. We've been working that long together and having support from PTAC, as you'll see through the slides. The objective or the project that we're working on was originally called the Oil Sands RPAS Digital Conspicuity Trials. It's a bit of a handful. It's really, as you'll see through the slides, transition to the Alberta RTM trials. And we're really enabling the airspace to enable drones to fly and reduce emissions. That's really the objective here. So we're going to go through the objectives, progress to date, challenges, and collaboration, as everyone else is. And so talking about the project, well, it starts with, at the bottom here is RPAS traffic management, otherwise known as RTM. That can be really dumbed down to be called air traffic control for drones. enabling drones to fly long range or beyond visual line of sight. And how are we doing that? Well, we're establishing an ecosystem of collaborators, and you'll see that in the subsequent slide, and seeking people to join that our alliance. We're building capacity by deploying infrastructure, services, and facilitating knowledge transfer, all for the purpose of taking advantage of an advantaged airspace that we're establishing here in Alberta. And we're doing that for the reason of delivering net zero objectives, reducing the footprint for the energy sector. And we're empowering routine beyond line of sight operations within a commercially rich environment. So progress to date, well, we have come from phase 1 of the trials, started in 2020, working with PTAC, TC Energy, and more importantly, NAV Canada and Transport Canada. We've built artifacts by deploying infrastructure and services, hardware and software, and flying drones, and proving it out that it can work here in Alberta. What that has yielded is new regulations, that those experiences that NAV, Transport and NAV Canada have benefited from, has allowed them to build new regulations, and more importantly, a new concept of operations for airspace. And so you can see over here, ultimately, what we're going to do here in Alberta, in northern Alberta to start with, is bringing advantaged airspace so that drones can fly beyond line of sight and be able to address those net zero objectives that we have. And so going forward, phase 2 of the trials, we're establishing a corridor between the Villeneuve and the Josephburg Airport in the Edmonton area, otherwise known as the Gretzky and Messier route. And then we're going to connect the northern and southern oil sands airspace, which we have named McDavid and Dreisaitl, with the Buckburger corridor. So providing examples of the new airspace that NAV and Transport Canada have envisioned that will unlock the airspace for the routine use of drones. And so some of the challenges that we have encountered along the way, well, I think everyone on this call would understand that the regulatory development process is slow. It's really consensus building. And when you can partner with agencies, it's very beneficial. The second piece of this learning that we have had is that technology demonstration funding, like CRIN, is absolutely critical. It's before commercialization, and really for commercialization to actually happen, it needs that foundation. So funding like this is essential. And then the last thing that we've learned is, OEMs, RPAS operator or AirPass manufacturers really need to be involved, and that there is, the ability to produce aircraft that are reliable and that can fly in the sky. We need those people to be aware and lined up with the regulations. And Boeing can be a backdrop to a little bit of that. And so looking forward, this is the perspective of the alliance that we're bringing together. You can see that starting in the bottom corner, we're bringing together technology suppliers, folks that have technology to be able to bring. We're bringing service suppliers, people that are flying and conducting operations, and then more importantly, end users, people that would benefit, organizations that will benefit from the wide use and adoption of drones. And so what we're seeking is more end users, more customers, more RPAS service suppliers and technology providers, all coming together with a commercial use case to be able to help us achieve net zero. So it's a call out for participants to join the alliance. And so ultimately, what we're asking for next steps is bring your drone-enabled use cases for achieving net zero, and come talk to PTAC or AIRMarket, and we're happy to bring you involved and get you involved in the alliance and enabling the airspace and enabling us to achieve net zero. With that, I'll close and yield it back to you, Marc.
Thank you, Lindsay, and very clear call to action. Thank you for that. Next speaker is from Arolytics. It's Stephan Becker, and Arolytics, longtime developer of innovation. I remember hosting Liz O'Connell, current president and CEO, when she was still at Saint FX, talking about trucks to detect methane in the Alberta and Western Canada oil fields. So over to you, Stephan. And
yeah, good morning. Thanks for saying my name so well, Marc. That's not always standard. Yeah, thanks everyone for the time, and I'm looking forward to sharing a little bit more about what Arolytics has evolved to in the meantime. It's kind of what Marc said. So Liz O'Connell, together with two other founders, they started Arolytics in 2018. Since then, a lot has changed in the market when it comes to methane reductions. If you follow very closely, or not even that much perhaps, but you know, ECCC recently launched new proposed regulations. In the USA, there's a lot happening now as well. As Arolytics, we try to play a very key part in that entire ecosystem to help oil and gas producers, upstream oil and gas producers, manage their methane emission. So a big part is what I would say is that we want to help data-driven emission management, very focused on methane. So we both have a consultancy side in the business, but a big part of what we do is a SaaS software product called AeroViz. And I'll be talking mostly about that today. So a big part of AeroViz is that really making sense of your data. The way how methane is working, methane management works today, and even the regulations are still creating very much an ecosystem or an experience where producers will have methane measured from different sources. Marc, I gave the example of truck. There are several of those. It ranges from satellites to a Cessna aircraft flying over, to drones, or a continuous sensor, as basically a webcam on a facility from the fence line that monitors what's going on. And then it all the way goes down to even someone physically going there with a FLIR or OGI camera to actually basically handheld find methane leaks. But with that, that's all different companies that we don't directly provide that service, but it sometimes therefore becomes scattered data for producers. And we're intentionally very focusing on those who are really trying to make sense of the data so that they can start actively reducing their methane emissions. So again, with that becomes the interesting part of all the data, because like you can imagine, a satellite can see very big plumes of methane. It can see small plumes of methane. And OGI, so when someone physically goes with a camera, they can look inside a building, for example, in a shack, whereas an airplane cannot. So there's a lot happening in that in terms of what is really occurring here for methane, where is it coming from, how big is it? So AeroViz, again, the SaaS product. And then a big part of what we pitch really is that it's about really the data flow and integrations. That is our main focus. So you have all these different sources, as I just mentioned. So you have your OGI. So these are just example data sources, different satellite companies, aerial companies, drone, truck, fixed. And then that's basically sensor companies. And then we as well are now starting to pull in basic information from the actual producer themselves that they can generate, such as operational data, or often called SCADA, if you're familiar with that. We add in equipment information and infrastructure. So all that is also added into as part of the onboarding process for producers in North America. We as well have a separate app that allows a lot more control of what's called the LDAR process. So that's the leak detection and repair process that producers need to be compliant with, just to really be able to provide a holistic, smooth experience where all this data flows into one product, being AeroViz. And then from there, we allow the producer to take a lot of sort of decisions. So here in the top one, emissions data integration. So visualize, integrate data from multiple sources, kind of what I mentioned. The really key one that we're now we're seeing a lot of value in for our customers and future customers, that it's about what, where, and why. So as you can maybe imagine, if an airplane flies over, it detects methane, but it's hard for that in a very quick instance to be able to say what was actually, where did the methane come from? They got some, there's some ways to do it sometimes after the fact, but it's not bulletproof yet. So at first, sometimes you want to know, was this actually a fugitive or a leak, or was this actually a vent? And often, again, if something flies over or different technology, I'm not trying to just single out that tech, but it can't fully say what it is. So we try to help with additional data, like operational data from the site, to help them, the producer, maybe see an AirVis, okay, that was a leak. We need to go out and do something about that, or that was a vent. And then that takes different approach. The second part to that is, where did that exactly come from? And as well, using that SCADA and operational data, there's a lot of information there from the producer where they can see, okay, we know there was a thief hatch popping, or it was an unlit flare, or there was maybe something else occurring that we know exactly where that methane came out from, because of what we can tell through the operational data. And then secondly, the most important one, that's the hard one really, and I'll be honest, we're not there yet, we're working actively to it, is the why did the measurement occur? So again, you might have the example of a thief hatch popping, fairly straightforward, but sometimes it could be that somewhere along the basic extraction process, a filter needed to be replaced. The current process is very much, you need to send a crew out to find the leak, then you see to send another crew out to find, like, why did that occur? That could be 2 months of process. And we're very interested trying to move towards the sort of the experience where someone can log into the product and can start pinpointing very likelihood where that originate, and then much more efficiently start repairing it to avoid another future methane measurement. So that's really a big focus of us right now to understand. And we're working with key industry partners, among others, Tourmaline, as together to really use their expertise and then build the product out. Other parts of AirVis with that, and I'll do these a little quicker, but is an improved LDAR workflow, so leak detection and repair. So track outstanding leaks, set notifications, connect work orders, all just that compliance side of it all to make that nicely and efficient for different producers. Program tracking, corporate targets, what are my highest emitters, repeat emitters, just those that are emitting the most methane, how can we quickly go at them to really, again, reduce our overall methane emissions. A lot of traceable data, easy audits when they might come around. We're focusing a lot as well towards supporting voluntary initiatives in the methane reduction space. You might have heard of things like an OGMP 2.0 framework from the UN. A lot of push as well to help producers to get all the data to be confident to sign up with something called like the OGMP, which is a very audacious way of how you really accurately know what your methane emissions are. Operation optimization, and then as well reporting required for methane specifically from scope 1 data that can be fed into third-party platforms. Yeah, and that's for me. Thank you very much. If questions, feel free to throw them in the chat, and I'll pass it back to Marc.
Thank you, Stephan. Yes, put your questions in the chat, and people here in the audience, note them down so you remember to ask them later on. Next speaker is from Calscan, and it's Doug Bezpalko. And Calscan, longtime company, reducing. So we talked about detecting. Doug will talk about what we do after we detect it.
Thank you, Marc. Oh, thank you. I pushed the button. I'm a little shorter than everybody else. It's all good. Good morning. Thank you to CRIN, and thank you for PTAC for all the support. It's been very critical to the development and the movement of the technologies that we are applying for the producers. Again, I like to always say the producers are at the mercy of the technology that's available, and it has to be very economical and actually fit for purpose for them to go ahead. Calscan has been mitigating methane emissions when it comes to controlling well sites with our electric solar powered equipment. And during this journey, we've been working with the regulatory board and the producers, and the next focus is tanks, the venting from tanks on sites, which is what I'm going to focus here on. I'm going to give you a bit of an education. Okay. Hello. How does this work? Oh, there it is. We're using an existing technology that we've applied in the past. It's been around for over 10 years for testing. It's called a GLCC, or a cyclone separator. I will just quickly go through this to explain to you what it is, and then I'm going to show you how it's going to be applied. We've been approved for a test with Synovus. Thank you to PTAC and CRIN for their tremendous support in getting us over the line. We're going to start manufacturing a unit and going to test on heavy oil, but I'll point this out as we go through. Okay. There we go. Gas liquid cyclone separator, cylinder cyclone. It was developed to reduce the sizes of separators. It is a two-phase separator, and where it started its journey or development was for offshore platforms to reduce the size yet be very efficient. So we've worked with the developers of this cyclone separator, the professors and the modeling software, which we do have and own, to develop them for the Alberta environment. I'll show you where we built a few of them. Again, it's a very soft, small footprint. There are no moving parts. Very simply, the liquid comes in at an angle tangentially. The centrifugal force spins. You get gas off the top and liquid off the bottom. Our modeling software will even give you the calculation of how much liquid entrainment there is in the gas, as well as how much gas there is in the liquid going in the bottom. Depending upon the viscosity and the process parameters, we're able to establish that very accurately. And our specialist is online for any questions that need to be answered. We built a few for Bakersfield where they wanted to do two-phase separation and measurement. These are pictures of what the unit looks like down by the well sites in the Bakersfield in the US area. I like pictures to show people it's actually real. These are ones we built here in Alberta. We built small ones for some of our producers to reduce the footprint, and it's highly efficient. Combined with our solar-powered electric actuators, we've not only eliminated the use of methane or fuel gas for controlling the well site, we've now been able to separate the gas from the oil. These are some test units we've built. Because of their wide range, they're very good and very useful in the testing field for provers. They've taken them out to sites to prove well sites and prove measurement. This is an interesting one. We built one for an offshore platform in Japan. After Fukushima, they were looking for methane. Japan was looking for methane to power their power plants. Guess where they were looking for methane? In hydrates at about 3,000 feet in the ocean. They came to us because when the methane comes up, there's a lot of water. So the unit on the right, they were able to, with great success, they removed the water from the methane, and they were burning a flare. The only problem they had with the well was the bore kept collapsing because it's ice and the heat. So they were trying to figure out how they were going to work with ice to get the methane, but there's a tremendous amount of methane trapped in the hydrates in the ocean. So here's an actual example of a unit that we built for them and shipped to Japan for an offshore application. Okay, so why are we doing this for tanks? Okay, let's go one more time. There we go. All right, we did some measurements. We worked with PTAC and with other producers to measure the amount of vapors off the tank. As you can see from this slide, with our turbine meter off the tank venting, the amount that was coming off. So I'm going to walk over here. So we were measuring about 250 cubic meters a day. And then when we plugged the gauge wire, it jumped up to 750 cubes a day. Currently, all the tanks are being vented to atmosphere out there and used as a separator. Here's another one. Every time the separator dumped, it showed you how it peaked to show you what's actually going on in the tank and the venting. So every time the separator dumped, as you can see, it peaked out at about 1,300 cubic meters a day on this application. So if Bridger happens to fly over, if the police happen to drive by at that time, sucks to be you, but hey, it also gives you the average is only 255 cubic meters a day. Yes. Oh, sorry. So on the slide, the dump valve was dumping, and every time it dumped, it was measuring 1,300 cubic meters a day, but the average was only 255 cubic meters a day. So a lot of our customers are using our turbine meter to actually measure the actual volume of gas coming out of the tanks. We've been taking samples to establish the amount of methane in that sample, because this is in the entire quantity. We've been finding that it's around 70 to 80% methane out of the tanks. If there's any questions or you need any more information, I'm here to speak to afterwards. So how does this apply? How is this GLCC going to be the wizard to help everybody out? Henry, our specialist, was sitting around and he thought, well, what if we came out of the pump jack, took the gas out before it got to the tank? So therefore, now you can attach a combustor to it and or apply it to your tanks or to your pipelines. We're now in discussion with several VRU vendors who are interested in putting this prior to their VRUs to knock the liquids out before it gets into the VRU. And for those of you who are familiar, VRUs are very difficult to size and everything else. So we're going to start this test. I'll give you an update. The letter was signed by Synovus. I'd like to give Synovus a great big shout out too, their technology department. And we're going to apply it on their heavy oil. We know this stuff works on light applications and gas water applications, light oil. So they want to see how it's going to help them out on their heavy oil application. So we're going to be starting manufacturing probably in the next month, get it in this spring, and we'll have some test results very quickly. It's going to be a small portable unit. And actually the GLCC will only be a 4-inch pipe. That's all it is. So any more information, we can chat later. Thank you, Mark.
And thank you, Doug. And I'll just mention, when he mentions heavy oil, it's about chops, and it's one of the largest methane sources in Western Canada. So it's very relevant. Next will be Ionata, and Robert Clark joining us from, I believe, Prince Edward Island today. We're making a transition from methane to CO2, and a game changer application from large scale carbon capture to modular, small scale, where there's 100,000s of such emission sources. And over to you, Robert.
Okay, thank you very much. Can everybody see my screen? Just should be up there now.
Yes, we can see your screen.
Okay, great, thank you. So thanks to everyone. And just to add our land reconciliation acknowledgement, I'm talking to you from Agabawit, the unceded territorial lands of the Mi'kmaq people, and very appreciative to be here. It's a beautiful place. So as Marc said, we have a bit of a change in tactic here. We're a carbon capture company, and what we're bringing to the table is a focus on the smaller emitters, stationary emitters and mobile emitters for that matter, planes, trains, and automobiles. Well, at least ships and trains. As you can see, this data that's in front of you right now is the Canadian greenhouse gas inventory, most recent data we have, I believe is 2021. And we have 51 million tons of emissions broken down. And out of that, 23% of those emissions, 20.03% of those emissions come from small emitters that are under 250,000 tons. And those emitters represent 87% of all stationary sources in the greenhouse gas inventory. So we have a large number of emitters that don't have a solution. And we are developing the necessary solutions, of course, for the large emitters, the boundary dams, et cetera. And we need those solutions to make an impact. But we also have to take that and leverage that infrastructure so that it serves everyone. And so that's what we've been able to do. And we've gotten a dramatic and very positive feedback from everybody we talked to. One of the other things that I'd like to point out here is that you hear a lot of times, like, what are we going to do about this green transition, this green energy transition? You know, there's going to be a loss of jobs. And I can guarantee you that right now we're going full force, hiring engineers, hiring fabrication companies, hiring technical expertise, hiring CAD operators. So we see this as a big boon to more and more jobs as we spread this out through North America, Europe, and Asia. So there's a lot of opportunities for all the traditional operators, from pipelines, you know, and trades for outfitting, welding, right through to technical engineering, maintenance, and operational side of it. So that's something that we're very excited about. And as I said, we've got a really interesting global application for our hollow fiber membrane contactor technology. The unique thing about our technology is that we have changed how you deliver amines to the emission source. Most of it has been through bubble tower, bubble trays, or pack towers, spray. We contain the amines inside small, hollow, microporous fibers that flows through. The exhaust gas passes by. The amines are retained inside the fibers, so that you have much less carryover. You have a much smaller system. Our system scales down. So as customers come in and they find energy efficiencies through various sources, through electrification, we can scale down and still provide them with that portion of carbon capture that is fossil fuel based, giving them a net zero at the end of the day. One of the interesting things about our technology is we're across globally across so many sectors. We have so much demand right now to do demos. What we don't have is the funding to do that. But what funding we have is directly proportional to CRIN, PTAC, and Intercan. Without that support, we would not have been able to bring in our investors. Right now, we have ARTROC, which is a U.S. oil and gas compression service company. They have 24 million horsepower of compressors out in the field right now that emit 98 million tons of CO2, and that's only their portion. And that's about approximately 1/3 of that total market out there. So we're looking at close to 300 million tons of CO2 that is catchable through various sequestration opportunities. And there's a number of all these lift gas processing sites that are very close to sequestration. So we look to make a huge dent in that 300 million tons of CO2 being emitted. There are additional investors, Yinsun and Dorian. These are marine companies. Dorian is a commercial LPG shipper. They're looking to move into CO2 shipments and looking to reduce the footprint of their LPG shipments. And because our system can actually be horizontal instead of vertical, this makes it fit ideally into a marine application as well. It isn't affected by a dynamic situation that you have. Yinsun is an FPSO fabricator and a leaser and operator. So what feedback we've had from a couple of multinationals, one in the US, one in Europe, is that when they're moving forward to do their various drilling programs and bidding on the various allotments that are out there from the various states, they're saying, and if you don't have a carbon capture component or a carbon mitigation component requirement in your lease offer, we're not going to bid on it, because we can't afford to be seen to be working in areas where carbon mitigation is not a core part of what we're doing. So there's huge demand for being able to bring up carbon mitigation in the offshore industry as well. Another the company that's interested in us doing a pre-engineering for a demo is MISC, which has a number of large commercial vessels that cover everything from tankers, LNG carriers, and commercial cargo ships. We're finishing up their pre-engineering, and they want a demo for availability in sometime in 2025. And finally, we have Waste Energy, Sharpie Viola, based in Europe, but have actually operations throughout North America and in Canada as well. And they're looking at us to do waste to energy and hazardous waste. And all of these emission sources are all in that range, what we've been seeing. And every one of these companies, when they found us, their first reaction was, this is what we've been looking for. You're the only ones who've been able to show that you actually have data from systems that are ready to go out for demonstration, and we want to be able to support that demonstration. And so that comes back again to CRIN, Intercan, and PTAC, and Tidewater, who have made that demonstration possible. Without that, we would not have been able to do our first Series A subscription for $18 million that was oversubscribed. So the project we're looking at through the good graces of Tidewater is on a LNG pipeline booster compressor that's just north of Edmonton. We'll be putting our system on site there late in 2024. We'll be doing full suite of carbon capture, so pre-gas treatment, CO2 capture, post-treatment for compression, and then off to storage sequestration as well. So it's a wonderful project in that it covers that full gambit of everything that's available and required to show the technology's full capacity and full cost and breakdown for both CapEx and OpEx. So the lessons we've learned so far, and I'm sure that everyone on this call and involved in this can attest that, boy, resources are in short supply. It doesn't matter where you go, what you look for, whether you're looking for fabrication, whether you're looking for engineering services, whether you're looking for technical services, people are in demand, and services are in demand, and material is in demand. So plan well ahead. The second thing is funding processes that, you know, a couple of years ago took, and I've been doing sort of entrepreneurial scale-ups for over 25 years now. And we've worked with the Canadian government on a number of instances, but everything post-COVID just takes longer. Everybody's overworked. There's a lot of demand, and it doesn't matter whether it's you know, institutional investors or government. That process is now 6 to 8 months, whereas before it was 3 to 4 months. So take that into mind. And one of the things I'd really like to stress is that outside of Alberta, which is a shining star globally, not only within Canada, but it's a shining star and recognized globally as a hotbed and excellent development for carbon capture and carbon mitigation technologies in general. Outside of that, we're well behind the rest of the world. And I'll just pop up a couple of examples of that. 3 examples. KNOC, which is the Korean national oil company, is signing deals in Indonesia. And part of these deals that I mentioned earlier, they're requiring carbon capture, carbon mitigation technologies to be a part of that before they will go in and bid on that process. So Indonesia is stepping up with carbon capture technologies and carbon mitigation technologies. Petronas, which is a Malaysian, of course, and has a number of operations in Canada. They've joined up with a couple of our partners that we're working with already to do carbon capture sequestration for LNG with a megaton sequestration offshore of Malaysia, and an FPSO, which will be reconverted into a carbon injection system that will contain carbon capture in it as well. And of course, in Europe, they're well ahead of us with Northern Lights. And you can see here on the right an example of Copenhagen carbon capture in Aalborg as well. The city of Aalborg, they have biomass carbon capture. This is all being sent via train and truck to sequestration pipeline, which will offload to discharge onto ships for offshore sequestration. And these are projects that are all funded, all under various levels of operational or construction. So, you know, we do need to see the rest of Canada and urge the rest of Canada to catch up to Alberta so that we can actually have a national program that is going to make the same kind of impact that we're having in Alberta. And so that's everything for me. Any questions? Be pleased to answer them at the end of all the presentations. Thank you for your time.
Thank you, Rob. And last on our program today is Dean Pix with Kinetic Automation, back to methane, electric actuation, technology from the space program or aerospace and applied to motorcycles. It's very exciting stuff. I'll let Dean speak to it.
Thank you, Mark. So Kinetic Automation, we are a motion control company that develops actuators and other hardware using shape memory alloy technology. And I'm here today to talk about a KVA actuator designed to replace methane venting pneumatics for the energy sector. So just a bit of an overview. We're going to look at some of the upcoming regulatory changes impacting Canada, North America. Take a look at the solution that we've brought to market. provide some updates on the project that brought this solution to market, and look at some of the areas that we can service to address methane venting issues, and then conclude with next steps to help industry take advantage of this impressive technology and products that we've developed. So big announcements came out of COP28 in Dubai. Our Minister of Environment and Climate Change, he basically followed through on a, let's say, proposal that was released in November of 2022, which outlined major emissions reduction targets for the energy sector. That kind of overshadowed some very interesting details that also came out of their policy announcements. Most notably, at least for our neck of the woods, was a proposal to completely prohibit methane venting from the energy sector. This is a pretty big step. Prior to this, if we look at Directive 60 in Alberta or similar regulations in the provinces, we have seen a prohibition or a banning for new well sites. But we all know, or perhaps some of us know, that there is a very large installed base of methane venting equipment in Alberta and further afield. And these policy announcements are directly targeting that installed base. So the proposed timelines are aggressive. 2027, I believe, was contained in the draft for complete prohibition. That does not give industry much time to get there. And as we progress towards these dates, we will be closely monitoring how this actually turns into written regulation. Provinces like Alberta, BC, Saskatchewan. Canada was not alone, though. At COP28, we were hearing very similar announcements from the US government, as stringent, if not more so, on targeting methane venting. So this potentially is of note because we are also anticipating scarcity for the solutions, as we're expecting a big upswell in demand for equipment that can resolve these problems. So I'll be presenting some reasons why waiting is not a good option for producers and other operators of the equipment. So what we're bringing to market, have brought to market, is the Kinetix valve actuator. It is a spring-loaded electric actuator. Does not run on methane, does not run on compressed gas. This product was developed through collaboration with the local industry here, with support from entities such as NGIF Industry Grants, Emissions Reduction Alberta, NRC RAP, CRIN, and PTAC, which we appreciate. So what did they ask us for? An alternative that they could both retrofit into the fields where they're operating pneumatic controllers and valve actuators, a solution that would also work for their new wells, which are currently under regulation, cannot run methane pneumatics. They needed a fairly stringent hazardous area rating. So Div 1 Class 1 is what we are rating the product at. This is meant to be a cost-effective alternative. So we have been able to present a strong business case where we can show lowest total cost of ownership. Some of these advantages come from the internal spring of this device, which basically takes or removes the need for a backup battery system, which can add cost, complexity, and additional points of failure in the system. So this is a system which is currently eligible for carbon credits through the tier system in Alberta. And this perhaps brings me to my earlier point about why not to wait. There is a limited window now, as of these announcements that we heard from COP28, in that as long as we are not past that prohibition deadline, there's still a crediting period. But I wouldn't encourage producers and other users of this equipment to act now in order to get full pull, let's say, on the credits available. Otherwise, the the economics will somewhat degrade over time, and you'll be effectively obligated to make changes with a reduced ROI. So time to act is now, and we encourage folks to take a good look at various solutions on the marketplace, including ours. So the project that brought us to this point allowed us to make some very impressive improvements over some prototypes that we had originally deployed. So we've had units operating in the field. The prototype is shown on the left hand of the screen. For over a year now, we've been operating at gas production sites in Alberta and British Columbia. So we've taken lessons learned from the field, worked very closely on the ground, talked to our customers, talked to the supply chain, and we have incorporated those learnings, that knowledge gained into our commercial product. Based on our experience with some of the applications, notably dump valves, we saw a need to increase the speed of the device. So we have incorporated a 4x or 4 times increase in stem speed to be able to service faster moving application needs. We also heard loud and clear that electrical power demands are high priority. So we've worked to optimize power consumption of this unit over the prototype. We've invested in the toolings to produce these en masse, so investment castings, extrusions, et cetera. This allows us to bring down the cost of our product, make it competitive in the landscape. And we've also looked at reducing the installation time, targeting less than 2 hours of instrumentation tech time to mount onto existing valves for retrofit or into new shacks as part of the greenfield modular construction approach. It's a quick mechanical connection followed by a fairly quick electrical connection. Bring power, bring signal to the device, essentially release the spring, which we have a nice mechanism to do so, user-friendly, at which point put it into service, walk away, and expect a long maintenance-free life from the product. Some of the technology advantages that we've built in allows for no internal moving parts in our powertrain. So we are able to directly act on the seat of a glow valve, reducing wear surfaces and maintenance cycles. So this product is now available commercially, and we look to partner with a variety of end users and supply channel partners to get the solution to market. I will get to questions towards the end. Thank you. So what are we targeting? Essentially, as I said, methane venting pneumatics. So where we've tested applications includes around the separator for liquid level control and back pressure control. We've also been running a trial on gas injection for artificial lift, and have seen good results from that. So we're now working with our partners to integrate these products into the standard separator package design for greenfield applications. We've also developed a variety of mounting bracketry to allow retrofits in the field. And essentially what's come out of this project is, yes, a solution for methane venting pneumatics, but if we take a step back, we're looking at a next generation control element. So for the process control and instrumentation engineers and technicians in the audience, I encourage folks to think about where they could potentially apply this novel motion control technology to address some challenges they may be having with their process. I think as we explore and push out the box of what this can do, we're going to continue to discover some of the benefits that it can provide our end users. So with that, we are interested to talk to end users, particularly in the natural gas sector, where we are, our mission is to eliminate the methane venting from the landscapes. We're also looking to talk with folks who are interested in delivering these solutions to the customers, oil field service companies, carbon credit companies, installers, and the like. So I'm happy to also announce through this presentation that we now have boots on the ground in both Calgary and Edmonton. So please reach out to us. We are headquartered in Vancouver, but reach out, connect, and we will then connect you with local contacts, get out to your sites, conduct assessments, and get you the solutions you need to your problems. So thank you very much.
Thank you, Dean. Thank you, Dean. And now we are open for your questions. And I'm sure we have some online, but first here in the audience, are there some things that come to your mind? And Doug, please, and your microphone, wait for the microphone, and we'll start the Q&A with Doug.
Dean, just a quick question on yours. Number one, are they 24-volt units or are they 120-volt units? And what's the current draw of the units?
Yeah, thanks for the question. So the commercial units are available in 24-volt DC for remotely located solar power sites. We also have a 120 VAC unit available for sites that have single-phase standard power available. The power question is really a question of application. So let's say our band is anywhere from essentially a handful of watts, a couple of watts for idle. We can develop full thrust in a normally closed position at just a couple of watts. That's just to keep the microcontroller running, all the way up to 100 watts for full modulation at rated stem speed. So everything in between is that, let's say, $1 million question for particular applications. So dump valve or back pressure control or other applications that have different motion profiles. I appreciate power is an important part of the question. So we have information in our product data sheets that can help. And then, of course, we can consult for folks that are really trying to penny pinch on their watts.
Perfect, and thank you. And I think we moved some chairs here to invite the speakers in the audience to join me at the front. And that's for Doug and Dean. So we'll go to the online questions if we have any. We do have any, and Sally DeWood from CRIN will ask them.
Hello. So for Lindsay, AIRMarkets, how do you aggregate your data for the drone to your database? From the drone to your database?
Well, it's a combination. Canada has gone in the direction of network remote ID. So basically, an internet-based endpoint will be used to collect the position of the drone and share that with Nav Canada. I think that's the question that they're asking.
Okay. Rob, are you connecting your information to any emission tracker software?
For the carbon capture? We have SCADA capacity. If this is the question for me, we have SCADA capacity that'll show all of the operational facilities, which includes the amount of CO2. But the way to track CO2 capture is how much do you liquefy, and that gives you a solid traceable ticket. So we liquefy, compress and liquefy so much on site that gets transferred to either a pipeline or whatever transportation device, and then that gets delivered to a sequestration. So that ticket all along the way is verifiable, traceable, and it can then be used for whether it's the 45Q or your carbon tax credits.
Okay. For Doug, how do you collect your data from on-site back to your head office?
What we do is we've got the flow computers that'll measure the venting off the tanks and off the cyclone separator. There's a SIM card inside to do it locally. You can plug a laptop into it locally, or you can tie it into your SCADA system as well if you want to go that far. So most of the test trials will be done just with a SIM card, probably collecting the data.
Okay. For Dean, do you use IoT tied to mobility solutions to collect the data?
Yeah, great question. So we do see our our node, if you will, as part of the larger control system. So at the moment, we tend to tuck behind the firewall of our customers. So the data is delivered typically to a SCADA system or plant control system, at which point then it can be retrieved as part of the regular data set of a regular operation. I think there's also a question in the back as well.
Yes. So let's just finish this follow-up. Can you compare actuators stroke time to pneumatic?
Yeah, so that was a really difficult question to answer about 3 years ago when we went and canvassed our target customer base. It was very hard to come up with a response time target. So we brought a best guess to our customers in the form of the prototype, tested it in various applications. So our what we found is that 1 millimeter per second seems to cover the gambit in terms of typical applications we saw. So we have rated our product for 1 millimeter per second. That is difficult to compare against pneumatics because it all depends on how they have set up their system, both in terms of pressure, line flow, diaphragm actuator size. But effectively, we believe anything that's currently being serviced for one of our target applications with a pneumatic actuator, we can come in with a retrofit solution and basically service that application.
Was there a question in the audience?
Have you been able to attach your technologies to be approved to, like, let's say you sell one of your units, how many carbon credits can you get per day for that unit? Has those studies been done? Any of you guys? So.
Yes. So because we can offer essentially a emissions-free solution, what we are able to do in terms of a carbon credit generation is take the, let's say, regulated maximum vent rate, which has been established by Directive 60, which roughly equates to 2 tons a day. I believe I had that on a prior slide. That's roughly worth over a 5-year crediting period, about $18,000 per unit. Now, the real trick or the real catch or caveat there, though, is this crediting period. So because we can see a prohibition now over the horizon, there's a shrinking window of crediting period, which is why, again, to maximize payback and return, do it today, don't do it tomorrow. Was a follow-up question there?
Well, are you asking kinetics or?
ISO approval on that? Have you gone through the ISO approval on that, or is it more of an engineering study?
The units themselves, we're able to actually cap the bleed line or the supply line that's going to the pneumatic controllers. So our unit itself, somewhat outside that ISO, I believe, because there is no consumption, no use of the methane. So it is a total cap. In order to quantify that, I would encourage collaboration with a carbon credit company that can help calculate and make those claims.
Currently, with our electric units, several producers are already capturing and getting the credits on it. They've either gone out and measured actually what's going on, and over the last few years, it's been applied for and is currently applied for, as well as ISO. It's all done. We're hoping the next step will be with this GLCC as well. If we can capture it and put it in series, let's say a combustor, there'll be a credit program there. But that'll be all. That's the next step for the unit.
There is one general question for all the panelists. Thoughts on how we get further support across Canada for what Alberta is doing with respect to carbon capture and emissions reduction?
Okay, I'm not speaking for Calscan because my boss is online too, so I got to be careful with this one. I feel we do a very lousy job in advertising what we're doing here. We should have billboards in Toronto explaining the great things we're doing. We should have commercials. We should have video clips, because currently I've talked to colleagues of mine who are working there. They don't have a clue and they don't get the message. So if there's one thing I'd like to do is somehow let's advertise like crazy.
Yeah, I would echo what Doug is saying. Certainly education, promotion of the industry and the solutions. That's low-hanging fruit. I have not yet seen, let's say, tangible proposals at various levels of government to help the sector get to the net zero. You know, they've set the bar, but the pathway to get there, I appreciate they're allowing choose your own adventure, but the incentive structure to get there is not well articulated, not well established. By way of example, we've seen some environmental or clean tech ITCs that came out in the last federal budget. Those, from our viewpoint, are not eligible. So that would potentially be a way to expand the scope of ITCs and help companies convert quickly to a net zero operation.
Lindsay, Stephen, Rob, do you have anything to add?
Sure, if I could, I think I have something that may be of interest to the team and to everyone. We were approached by Fortis, BC's natural gas residential commercial supplier, who had done a call with Foresight for small scale carbon capture. And we weren't too surprised when they contacted us as part of that call to say they were very interested in looking at doing some kind of a project with us. And our response to them was, that's wonderful. We really appreciate this, but we don't need to do a project with you. What we need to do is clarify the rules and regulations for carbon capture, for BECCS and ordinary carbon capture in the province of BC. You've got a province here who is looking to eliminate the use of natural gas within the province, yet their number one export is coal. You've got a province that has one of the lowest kilograms of CO2 per electrical gigajoule of generation in the world. Yet any biomass carbon credit project, all those carbon credits are irrevocably for the past, future, and forever property of BC Hydro. We can't get investors to invest in this province without sorting out these questions. And so Foresight and Carbon Management Canada, we presented them with the outline of what a study would need to cover for all times, all certain, not just our technology, all technologies that we're going to do something in this area. And they took that forward, and they are now sponsoring a $300,000 study in BC to help eliminate some of these roadblocks. And we just need to bring that to every province and say, look, guys, you're putting billions of dollars into subsidizing battery plants. Guess what? There are massive opportunities for every one of these technologies that we've talked about today, for jobs, for wealth creation, for just families and engineers and technicians, everybody. So don't be so singularly focused.
I think I'll just jump in here. Yeah, I would echo the advertising and sharing and showcasing. If we can drive collaboration and adoption, that's not an easy thing to do, but I think we don't really advertise very well all the wins that we have. So I'd echo the gentleman before me.
Yeah, thank you, Lindsay. And not seeing more questions, but I want to give an opportunity to Stephan there were a lot of questions about data, and that's what your business is. And if you have any comments, Stephan, please go ahead.
Yeah, I think just almost bring back to I guess combine those two questions almost. I think a big part too that would really help in all these spaces as well, just collaboration between the different providers and then even the producers. I think a lot of producers, from what we see too, they're really trying to do better in their methane reductions and tell the right stories and start getting comfortable to put them on, their public statements or anything like that. But I'm hearing many here talk about, for example, that they're integrating SCADA data. You know, and even in the chat, there was questions about API integrations and all that. So there's a lot of data that needs to flow between all these different producers and sort of us sitting in the center of it all. The smoother all this data can move along, the more equipped everyone is with the right information to take some very effective approach to methane reductions or to CO2 reductions, how broad you want to take that. So I think in itself, and I think so far I've seen this go quite well, I find here in Canada at least, is that we're all working well together towards this common cause. And I think if we just continue to keep that up and meet among each other, and if someone has opportunity to build or expose an endpoint for an API, let's try to make that happen, just to share data among each other, because I think we all know nowadays, just with the internet of all, data is such a key source to keep us moving forward, and particularly when you talk about data science and integration of some sort of AI models on top of that, they can start getting really well, but if the data is scattered, it just simply does not work as effective. So that'd be my main comment. I think that just kind of touches on perhaps the two combined, the questions there combined.
Thank you, Stephan, and that will be the concluding comments. Thank you, everyone, for attending this session. Yeah, we should give a hand of applause to our panelists, speakers in person and online. And thank you for the audience for your questions and your participation.
Thanks, Mark.
Thank you, everyone. Cheers.